Hello and welcome to CS264. This is Lecture 6 and this is Lesson 4. In this lesson we're going to look again at some more features of object-oriented programming, and in particular we're going to look at polymorphism using C#. As we mentioned previously, polymorphism means many-shaped, and it occurs when we have classes that are related to each other by inheritance. Okay? So we talked about the different forms of inheritance in the last lesson, and we saw that we can create hierarchies by extending classes and interfaces to inherit attributes, that means the fields, the properties, etc., and the methods from another class. So polymorphism is all about using those methods to perform different tasks using a single action, like a method, for example. So central to polymorphism is method overriding, and we're going to see that in this lesson. And probably also see a little bit about method overloading, of course, as well. So if you think about a base class then called shape, let's say you have a base class called shape, then this class could provide a method requiring overriding later called getArea. So if we decided to extend shape to create other classes called, say, rectangle or circle, etc., then these classes could override the shape's getArea method, each implementing a specific formula for calculating that shape's area. So the base methods requiring their own definition and implementation in derived classes, they're referred to as virtual methods in C#. So according to Microsoft, at runtime, when the client code calls the method, the CLR looks up the runtime type of the object and invokes that override of the virtual method. In your source code, you can call a method in the base class and cause the derived class's version of the method to be executed. Okay, so you can go and look at the docs here to find this in more detail, but that's the theory bit. But we'll work through it with using an example for shapes. So it's a practical example. It's based on the one given in the Microsoft reference. We're going to look at a base class called shape and a derived class called rectangle, circle, and triangle. Three derived classes. So let's say we have a canvas to which shapes are added by the user. So we don't know which shapes will be added, but we do know that each shape will have specific rules when drawing on the canvas. So you won't know at compile time which types of shape the user will create and add to the canvas. The application has to keep track of all of the various types of shapes that are created, and it has to update them in response to the user's actions. So we can use polymorphism to solve this problem in two basic steps. The first step is to create a class hierarchy in which each of the specific shapes, circle, rectangle, and triangle, these classes derive from a common base called shape. And second, we use a virtual method to invoke the appropriate method on any derived class, say for drawing that shape in the canvas, through a single call to the base class method called draw. Okay, so that's a bit more complex, but you know, it should make a little bit more sense when you see an example, and you can go back and read this again afterwards, of course. So I have a program called My Shapes. Let me load up my shapes, and hopefully it will work fine for me. My shapes is here. Okay, so let's. You'll notice I've given you quite a lot of programs, you know, so all of the examples are there, and it's worthwhile working through them at your convenience. Okay, so here we have my shapes. Okay, looks like it's heavily commented as well. Okay, but it's not too long. It's not too bad. Okay. Okay, so program. Let's have a look at it here first. So public class shape. Okay. So shapes have this reference point on a canvas. So we're producing. So yeah, I've created up these properties X and Y. Okay. Now you'll notice with this that previously I would have had sort of a private int little x and private y little y, and then I would have created a property that referenced them as worked with these. But actually, this is shorthand notation. I don't have to do all that extra work. Okay. But I'm saying that, you know, the value, we can get the value of x and y, in other words, the pointer location on the canvas of any particular shape using by referencing the x property, but we can't set it. Okay, that can only be done by protected, so it's only can be done within the class shape or within any of its derived classes. Okay, so we're setting this virtual method draw. Okay, that is explicitly called by the overriding method. So this is, we're drawing the base shape. Okay, so we're saying it's a virtual method, and we want this to be overridden. Okay, so that's how we do this. Okay, with polymorphism. So because each each shape will need to draw its own work or do some work itself. Okay, so we have a class circle, extends shape, and again we're overriding the draw, so we're drawing a circle at this point here, and then we're calling the base.draw because base allows us to be able to call the base class method that's being overridden. If we want, we might not need to do this, you know, but we might just do it anyway. Okay, so that okay, so there's some overloaded circle constructors. Okay, so it's not too bad. I just have a couple of circles there, and it's easy to do that. And you'll find that I've done the exact same work for a rectangle, except we're drawing a triangle, I'm drawing a rectangle, and my main program then draws the canvas, adds some shapes, creating a new rectangle, a new triangle, a new circle. The reason I overloaded it was to show you I could just add 2 circles. And then we iterate over each shape in the canvas. Okay, it's a list of shapes, and we draw the shape. Okay, now you'll notice that this one calls the base as well. This one calls the base. Yeah, so they all call the base as well, so it's not too bad. Let's go and have a look at this running. Yep, drawing a rectangle, performing the base shape drawing as well if we had to, if we wanted to. Okay, and we could say we don't want to do this, of course, and then you just leave out that line here. But all that matters is that we can use base as in an overridden method to call the method that's been overridden. Okay. So we can as I said with this, we can add to the canvas easily. Drawing the shapes just involves iterating over the list of shapes, calling the draw method for each shape, and polymorphism then ensures that the correct overriding method is drawn at runtime. So we go back. Yeah, we saw we draw a rectangle, we drew triangle, we drew circle. Okay. If we neglect to override the draw method, then the base one is called by default. So no error is generated here. Okay, that's important to realize that. If we neglect to override the draw method, the base class draw is called by default. You know, the fact that we've that it was virtual means that, you know, we can override it if we want. Okay. Notice also that a derived class can override a base class member only if the base class member is declared as virtual or abstract. Okay, and we see more about abstraction in the next lesson. Okay, so when we think about polymorphism in a bit more detail, we see that there's something called static or compile time polymorphism and dynamic or runtime polymorphism. So static polymorphism is called early binding, okay, and that's a mechanism of linking a method or a function with an object during compile time. So method overloading is an example of static polymorphism when we've seen overloading before. And overloading is the concept whereby method names are the same, but each one has a different set of parameters. And we overloaded the circle constructor here, okay? That's overloaded constructor, because the signature is different. Okay, so with overloading, the method has the same name but different signatures. So it's known as compile time polymorphism. And the decision about which method will be called is made at compile time. So I demonstrated, as I said already, the circuit class constructor overloading. At compile time, the C# compiler checks the number, types, and parameters passed and determines which method to call at compile time. An error is thrown if no matching method is found at compile time. Dynamic polymorphism then, that's known as late binding. But it was early binding, that was late binding. Maybe I should just make this a little bit more prominent here in the notes. Okay, so late binding, that happens at runtime, and it refers to the selection of the appropriate method during execution. So the method name and the method signature must be the same. And we've seen this already, okay? Method overriding is an example of dynamic polymorphism. Method overriding is achieved using inheritance, as we've seen in the last lesson. Okay, so in summary then, we looked at and learned about the different forms of polymorphism available in C#. We discussed overriding and overloading as examples of dynamic and static polymorphism. You'll note that the virtual members methods of a class remain virtual indefinitely, and classes derived from derived classes all have access to the members and they can override them. You can stick this at any time in the hierarchy by using sealed override instead of override, and that stops it. Okay. You'll notice already as well that we use the base keyword. Using this, the derived class is able to access the base class method, in other words, the overridden method. Okay, thank you very much for watching.